EtherChannel. Prepare the switches for the lab. The instructions in this lab assume that the switches are running using the final configuration from lab 3.1. Static VLAN trunking in BTP, the previous lab. Configure EtherChannel with Cisco port aggregation protocol. The first EtherChannel created for this lab aggregates interfaces 11 to 12 between ALS1 and ALS2. Make sure that you have trunk link active for those two links with the show interface trunk command. Okay, 11 to 12 between ALS1 and ALS2. In my case, between ALS1 and ALS2, I'm using 1.1 and 1.2 in both sides. Okay, on ALS1 and show interfaces trunk. Okay, 1.1 and 1.2 trunking, very good. Native VLAN encapsulation. When configuring EtherChannels, it can be helpful to shut down the physical interfaces being grouped on both devices before configuring them into channel groups. Otherwise, the EtherChannel misconfigured may place these interfaces into error disabled state. The interfaces and port channel can be re-enabled after the EtherChannel is configured. On ALS1, bundle interfaces 11 and 12 on the port channel 1. The most desirable option indicates that you want the switch to actively negotiate to form a port aggregation protocol link. The port channel interface numbers are locally significant only. On the 2960, the number can be anything between 1 and 6, and they do not have to match end-to-end. If it is possible, use the same number on both sides of a port channel so that the coordinated troubleshooting is less complicated. At the very least, clearly document the configuration. Okay, configure the both interfaces, shut down, channel group, and not shut down. Okay, ALS1, configure terminal, interface range, gigabit 1.1 and 1.2, shut down, channel group 1, mode desirable. And finally, no shutdown. Okay, and this will be the port channel 1. This obviously you need to configure another side on ALS2. After you configure EtherChannel, a virtual port channel interface is created automatically that represents a logical link consisting of the bundle of physical interfaces. The port channel interface will automatically inherit the configuration of the first physical interface that was added to the EtherChannel. All configuration changes applied to the port channel interface will then apply to all the physical ports bundled under this interface. The configuration of the physical interface that are bundled into an EtherChannel must be consistent. Otherwise, the bundle may never form or individual links in the bundle may be suspended. When physical interfaces are added to the EtherChannel bundle, the administrator should not make any configuration changes directly to the physical interfaces. Any necessary adjustments should be made to the appropriate port channel interface. Before configuring the EtherChannel bundle on ALS2, issue the command show EtherChannel summary on ALS1 and notice that the status of both the bundle and the individual interfaces. ALS1 and show EtherChannel summary. Okay, this is the port channel state, the logical interface SD, D for down and S uppercase layer 2 protocol, port aggregation protocol, and physical ports state I uppercase stand alone. Okay. Port aggregation protocol is preventing the bundle from forming because the other end is not speaking the port aggregation protocol. Okay, using the same commands as above, configure ALS2. Interface range gigabit 1.1 and 1.2. Shutdown channel group mode desirable. Okay, channel group 1 mode desirable. And no shutdown. Okay, on ALS1, verify the show EtherChannel summary. Okay, the port channel state SU uppercase, S for layer 2, and U in use, and physical ports on P uppercase bundled in a port channel. Okay, verify on ALS2 and show EtherChannel summary. Okay, in use layer 2, U for in use port aggregation protocol, bundle in a P for bundle in a port channel. At this point, the system does not consider interfaces 11 and 12 as individual trunks, but as a components of interface port channel 1. The output of show interfaces trunk illustrates this. 11 and 12 are not shown while the port channel is operational. Show interfaces trunk on ALS1. Show interfaces trunk. Okay. Gigabit 1.1 and Gigabit 1.2 are not shown. Instead, port channel 1 is shown. Okay. Configure EtherChannel with AAA A of 2.1x LACP. Using the previous commands, configure the link between DLS1 and ALS2 on ports 7 and 8 as an A of 2 LACP EtherChannel. Okay, between DLS1 and ALS1. Between DLS1 and ALS1 using ports 7 and 8. port channel number 2. Okay, in my case, I'm using gigabit 01 and 02 between DLS1 and DLS2. And this will be the port channel number 2. You must use a different port channel number on ALS1 than 1, because you already used that in the previous step. The port channel number you use in DLS1 is locally significant and can be anything between 1 and 48. If it is possible, use the same number on both sides of a port channel so that coordinated troubleshooting is less complicated. At the very least, clearly document configuration. The configure port channel as LACP. Use the interface label command channel group number and mode active. Active mode indicates that the switch actively tries to negotiate that link as LACP as opposite to port aggregation protocol. Okay, both interfaces shut down channel group 2 mode active and not shut down. On DLS1 and verify. Okay, first of all, on ALS1, configure terminal, interface range, gigabit 0, 1, and 2, shut down, channel group 2 mode active, and now shut down. Okay, DLS1 exit interface range, gigabit 0, 1 and 02, shut down, channel group 2 mode active, now shut down. Okay, verify, and on DLS1 show EtherChannel summary. EtherChannel summary. Okay, layer 2, U for in use, protocol LACP, state bundle in a port channel. Verify on ALS1 and show EtherChannel summary. Okay, there are two port channels. The second is the LACP protocol. Layer 2 in use bundle in a port channel. It's very good. Explore misconfiguration. In this step, you will intentionally misconfigure an EtherChannel bundle on DLS2 with parameters that do not match the distant end switches to observe the results. Okay, to begin, configure an EtherChannel using LACP on ALS1 interfaces 9 and 10. Assign EtherChannel to port channel number 3. Okay, 9 and 10, and apply these comments. On ALS1 will be channel group 3. Okay, on ALS1, 9 and 10 are connected to DLS2, will be port channel 3. In my case, I'm using 03 and 10 to connect ALS1 to DLS2, and will be port channel 3. active for LACP. Okay, on ALS1, configure terminal interface range gigabit 03 and gigabit 10. Shut down channel group 3 mode active and now shut down. Next, configure EtherChannel in on mode on DLS1. Interfaces 11 and 12. Assign this EtherChannel to port channel number 12. Okay, 11 and 12, port channel 12 and mode on. Mode on will not use a specific protocol. Okay, 11 and 12 on DLS1. Okay, this is the connection to DLS2 and will be called port channel 12 with no specific protocol. In my case, I'm using gigabit 11 and 12. Okay, on DLS1. Configure terminal interface range. Okay, but this will be port channel 12. Okay, interface range gigabit 1, 1 and 2. Shut down channel group 12 mode on. Okay, no specific protocol. And now shut down. On DLS2, configure EtherChannel using port aggregation protocol on interfaces 10 and 11. Assign this EtherChannel to port channel number 40. Okay, 10 and 11, 40 desirable for port aggregation protocol. Okay, 10 on DLS2, 10 connected to LAS1 and 11 connected to DLS1. Obviously, this is an intentional misconfiguration. Okay, but configure it anyway. Okay, 10 and 11, 40 desirable. Okay, in my case, is 10 is 10 on DLS2 and 11 is 11 on DLS2. Okay, go to DLS2. Interface range gigabit 10 and gigabit 11. Shut down channel group for the mode desirable. Now shut down. And show the channel summary. Okay, layer 2 default down port channel 40 port aggregation protocol. I uppercase both physical interfaces stand alone, okay, not bundled. The first interface is attempting to communicate with a distant interface that is configured for LACP. This results in the interface being in a standalone state, the I uppercase. Another interface attempting to communicate with a distant interface that is configured not use a signaling protocol. So the interface is in down state, D uppercase. Okay, verify the messages on the switches. Okay, for example, on ALS1, ALS1 is connected to DLS2, but gigabit 10 is suspended. Okay, because LACP currently not enabled on the remote port. The remote port for gigabit 10 is another gigabit 10 on DLS2 and is intentionally misconfigured with port aggregation protocol. Okay, and ALS1 verify and show EtherChannel summary. Okay, space and gigabit 10 is configured with LACP, but DLS2 in the another side show EtherChannel summary. 10 is configured with port aggregation protocol. Okay, and different protocols on both sides. So ALS1 says gigabit 10 is suspended. Fix all. Okay, and go to DLS2. Show EtherChannel summary. The port channel 40 uses gigabit 10 and gigabit 11. Okay. Okay, this is not good because gigabit 10 on DLS2 is facing ALS1 and gigabit 11 on DLS2 is facing DLS1. Okay, and using port aggregation protocol. Okay, and remove this configuration. Configure terminal interface range gigabit 10 and gigabit 11. Shut down. No channel group for the mode desirable. Okay, port aggregation protocol. Okay, channel. Okay, verify ALS1 in the another side. Show EtherChannel summary. Okay, ALS1 uses gigabit 03 and 10 to connect DLS2, 03 and 10 to connect DLS2, and uses LACP using port channel 3. Okay, so you need to configure the another side like this. Okay, okay, on DLS2 interface range gigabit 03 and 10. Shut down and channel group 3 mode active for LACP and no shutdown. Verify on LAS1, show EtherChannel summary. 3 port channels, layer 2 in use, LACP, uppercase P for bundle in a port channel. Okay, the 3 interfaces are very well configured. Okay, now verify DLS1 and EtherChannel summary. Okay, port channel 2, the connection to ALS1, this port channel 2 uses LACP, very well configured, but port channel 12 no mode on, no protocol specified. Okay, very well. The DLS2 verify and show EtherChannel summary. Okay, port channel 3 very well configured. Okay, port channel 40 still exists. Port channel and no interfaces assigned. Okay, verify and show running config. Okay, port channel still exists, port channel 40. Okay, remove this and configure terminal. Configure terminal. Okay, no interface port channel 40. Okay, ready and verify. Show EtherChannel summary. Okay, no port channel 40. But you need to configure the EtherChannel between DLS2 and DLS1 and configure gigabit 11 and 12. Okay, remember on DLS1, no specific protocol, mode on, and port channel 12. On DLS2, configure terminal interface gigabit 1 and 2. Okay, range, shutdown, channel group 12 mode on. Okay, channel group 12. Okay, no shutdown. Okay, verify and show EtherChannel summary. Okay, very good configured. SUP. Okay, challenge. The topology still has redundant links that you can aggregate. Experiment with the other port channel modes using the question mark on the physical interface command, channel group number, mode, and mark question. Look at the descriptions and implement the remaining EtherChannel in different ways. Okay, for example, on DLS2, configure terminal. We will create another port channels. Okay, This will be called port channel 4. Okay, the connection between DLS2 and DLS2 and ALS2, and another port channel 5 Okay, first of all, DLS2 interface gigabit 01 and 02. Okay, range again. Shut down. Channel group 4 mode mark question. Okay, active enable LACP unconditionally. Okay, no conditions. Passive enable LACP only if a LACP device is detected in the another side. For example, you can configure passive. For example, configure active on DLS2 and passive on ALS2. Okay, and mode active for LACP in this side. Now shut down. Okay, and on ALS2, okay, configure terminal interface gigabit 01 and 2. Okay, range. Shut down both interfaces. Channel group 4 mode passive. Okay. The condition is that the DLS2 were configured with the active command. Okay. And now shut down. Okay, and show EtherChannel summary. Okay, look at the number 4 uses LACP and okay, W waiting to be aggregated. Okay, wait some seconds and verify again. Okay, now very well configured SU and PP bundle in a port channel. Very good. Verify on DLS2 and show the channel summary. Okay, very well configured. Okay. Now configure port channel 5 between DLS1 and ALS2. Port channel 5 between DLS1 and ALS2. Okay. Okay. On DLS1, configure terminal interface range gigabit 03 and gigabit 10. Shut down. Channel group 5 mode and more question. For example, desirable enable port aggregation protocol unconditionally, but if you choose auto enable port aggregation protocol only if a port aggregation protocol device is detected in the another side. Okay, and you can configure DLS1 with the desirable command and ALS2 with the auto command. Okay, desirable, no shutdown. Okay, now configure LAS2. Configure terminal interface range gigabit 03 and gigabit 10. Shutdown. Channel group 5 mode auto. No shutdown. Okay, verify on DLS1 and show EtherChannel summary. And look at this number 5, very well configured ALS2, and show EtherChannel summary. Number 5, very well configured port aggregation protocol. Okay, very good. Using the channel protocol, port aggregation protocol will make sure that in subsequent channel group number mode command, only desirable and auto keywords are accepted. Conversely, using channel protocol, LACP will make sure that in subsequent channel group number mode command, only active and passive keywords are accepted. Okay, for example, on DLS2, the port channel 4 with LACP, you can do this, okay, gigabit 01 and 02. Interface range, gigabit 01 and 02. Channel protocol. My question. Okay, you can set the LACP protocol on these two. Okay, LACP. And if you will configure the channel group 4 mode. My question. You have all these options and only will be accepted the LACP options in active or passive. Try to use desirable. Already part of the channel with a different type of protocol enabled. Okay, so it's not accepted. Auto will not be accepted, but if you use active, will be accepted. Very good. Okay. The end state from this part of the lab is that there are no single interfaces trunk. All connections between switches will be port channel interfaces consisting of two members. Now configure and test EtherChannel load balancing. Configure the load balancing method. The load balancing method used to send traffic through EtherChannel is a global setting on the switch. All EtherChannels on a given switch will use the method selected for that switch. The load balancing method used at either end of an EtherChannel bundle do not have to match. The available methods as well as the default method used varies by hardware platform. By default, Cisco Catalyst 3560 and Catalyst 2960 switches load balance using the source MAC address. Okay, verify on DLS1, on ALS1, show EtherChannel load balance. DLS1 show EtherChannel load dash balance. Okay, the configuration for the EtherChannel load balancing uses the source destination IP. You can use MAC, IPv4, and IPv6. Change the load balancing on ALS1 and ALS2 to source destination IP. Okay, because on this lab the default configuration is based on MAC and the instructions says change to IP. Okay, and use this command, port channel load balance, and the option. Okay, ALS1, for example, configure terminal port channel load balance, mark question, and you have these all options. You can change to source destination MAC or source destination IP. Okay, I will change to source destination MAC. And verify no, it's show load balance. Okay, now it's using MAC, and I will reestablish to the source destination IP, configure terminal source destination IP, and okay, source destination IP. On ALS2, verify show EtherChannel load balance. Okay, source destination IP, and verify. When this is configured on switches, you can use the test EtherChannel load balance command. Using this command, you input a source and destination value, and the switch will respond with what member interface of EtherChannel will be used. Okay, for example, on LAS1, test EtherChannel load balance, mark question. Okay, no EtherChannel option. iOS layer 2 switch on VIRL does not support that command. Okay, does not support this command. But for example, you can use this test EtherChannel load balance interface. For example, port channel 1. Set the IP. Okay, remember this is ALS1, and the IP is 103, and ALS1 IP 103. Okay. Okay, for example, a destination, and we'll use fast Ethernet 11 of port channel 1. But if you will select another destination, will use 12 port channel 1. Okay, obviously is balancing between the two interfaces. End of lab. Do not save your configuration. The equipment will be reset for the next lab. Okay, thank you very much.